Okay, thanks for coming to this talk. And what time is it? Oh, because of the alarm, it's only Compose o'clock. So if you don't plan to draw anything on watches, don't worry. I think what you will learn here can apply on Android, on iOS, on Compose Desktop, and other stuff. But first, you can draw programmatically. But why? Why would you want to draw programmatically? You can do it with a pen, right? So you can do pixel-perfect things easily. Of course, in real life, there are no pixels. But you can also make it any shape you want, not just rectangles and circles. You can also animate stuff, which can be very entertaining, very cool, very way too much also, but you can do it. And you have the power of code, so you can automate or batch do things, animate a lot of elements, whatever you want, variables, loops, abstraction, Kotlin code. You can do cool effects. I know it's a bit, do cool effect, what does it mean? Depends, but anyway. But we already have drawings at home, right? We have blocks, we have shapes in Compose, we have modifier background, and with that we can do a lot of things, right? But it's very limited. If you, by the end of this very short talk, I think you will see what the Compose canvas, or Dscope, as I like to call it, is how more powerful it is compared to just doing box shapes and backgrounds. And it's not that hard either, in my opinion. So, okay, why do it in Compose UI? Because the API is Kotlin friendly and concise. It's also optimized for high performance. For example, they leverage JVM inline value classes, or the former name was inline classes. Basically, it's like an object, but you don't need to allocate memory. So you can do it in high hot passes, which is the case for rendering, because your code might run at 120 frames per second. Sometimes more if it's something that you do over. Maybe you draw the same shape at different places 100 of times. So you multiply that by the number of frames. So that's why being optimized for high performance is very important. It's also multi-platform, run on Android, iOS, Wear OS, desktop, and the web. Yes, the web too. And it has a good developer user experience in Android Studio, like Live Edit. I think it's in Fleet it's also becoming a lot better. So that's why you want to do it in Compose UI. There's a demo, there's a live demo. I hope it works. I think it will. I want to touch on some use cases because drawing, there are many possibilities and probably some that you might not have thought about. So of course, watch faces for Wear OS. I think you got the theme, but also you can do maybe a custom loading animation that makes your app look a bit more unique and less boring, while something that needs to be long is long. Maybe you make it long just so that the user don't believe it's too instant. I don't know if you can create app icons if you are creative enough. You can draw even an icon just in Compose, and you can generate a PNG file. You can do splash screens, but please don't do splash screens manually. Use Android X splash screen on Android. Use the writing on iOS that is built in. Don't delay your app when you should not be delayed. You can also add niceties like custom art and backgrounds. For example, you have a card and you want to just draw a few, I don't know, a star or just a few lines that just make it look a bit nicer. Maybe just subtle, maybe very transparent, but not too much, so that it makes it a bit unique. You can do that with the canvas. And you can generate some images, app icons, but anything else. But you can also generate transparent videos, maybe. And Christmas and birthday cards as well, like those. And this is inspired by Anton Arhipov, who is making circles by Anton. So basically, he's using a compass and drawing circles. But sometimes he's also doing it with code. And you can check out his GitHub repository here if you want to see what it has to offer. That's not what I used to do the circles and ovals above. Yeah, it's made all with circles, ovals, and for loops. It's very, very simple, actually, to do that. And colors, of course. OK, so to draw, there are several entry points in Compose. You have a canvas, where you have to specify some size constraints. For example, you can specify an exercise in DP, or it could be whatever based on where it is. You have the modifier.drawBehind, which is almost the same thing. Actually, Canvas is using modifier.drawBehind from behind. You have draw with content, which allows you to decide when the content that this modifier applies on, when it's drawn. If you want to do it before, after, maybe in the middle, so draw something at the top and behind all at once. There's also draw with cache, which helps you cache the size and some other stuff. Please just look at the documentation. It's very useful one. Just look at the documentation. This is a lightning talk. I won't read the documentation for you here. There's also o'clock canvas. So o'clock canvas is something I made that works on watches. Because on watches, you don't. If you want to do a watch face, you cannot use views, and you can only have a canvas. And so modifier relies on views internally for Android. So I needed to have something without the modifier and deal with the layout in another way. But this can still be integrated into an Android app. And so all those types, at some point, they give you the Dscope interface. So that's what for the three ones that are not dimmed, those exactly give you the Dscope receiver, and that's where all the magic happens. And the other one bring you something else where you can also access a Dscope. So Dscope, what can be drawn with it? I told you about use cases, but technically, how are you going to fulfill those use cases? So first thing is points, lines, rectangles, or rounded rectangles, circles, ovals, and arcs. Nothing more when it comes to shapes. But you also have paths, where you can combine all of that I said, and also basic curves, which are not that hard as well. But if you go very deep, it becomes hard, but you don't have to. But basically, you take 3 points, and curves comes out of those 3 points. So you just test, and you find something. You can draw text as well, images, and graphics layer, which I will talk about later on, but don't worry, it's not something super hard. So now let's explore Dscope in the IDE very quickly. And presentation mode, sorry. So here in o'clock canvas, if we look at this is a Dscope. And what I have available here, as I told you, rectangles, circles, lines, arcs, images, ovals, paths, points, rounded rect, then some extension that I made myself, some stuff to transform the canvas if you want to move it, if you want to flip it. And there's also inset if you want to shrink it. And there's draw text, which technically is not defined inside the Dscope interface, but is still available on the Dscope context. So you can look at it's all documented, and it's really nicely documented, and it has a lot of default parameter values. For example, if I want to draw a circle, and I want it to be black, I just write circle color black, and I think it's rendered somewhere, but because I draw on the top, okay, now probably something should be black. Yeah, this one. And so it's trying to find where it's putting the largest circle that will not overlap in the size where you are drawing. So that was a very quick demo, if I can say, about Dscope. Everything is there. But you want to achieve high efficiency, especially if you don't want your watch to show the hours for just 2 hours. You really need to look at efficiency. And so with Compose, you can do some things that will help you achieve high efficiency. First thing is work avoidance. Avoid causing recompositions, and don't re-render if not necessary. So what that means is that if you have a state that changes often, but you don't always need to redraw for all those state changes, that narrow it down to something that will change less often, and only based on whatever, and for that you can use remember, derive, saved off. It's useful for all Compose apps, and it can also be leveraged when you are drawing stuff with Compose. So yeah, don't do stuff that you don't need to do. And also read state at render time. When I mean render time, if you look at the o'clock canvas thing, here, if I wanted to say use remember, it will not allow me to because the lambda is not a composable one. So this is this code is called at render time, and that's different from the composition time, which is just before I call that o'clock canvas or modifier draw behind whatever. And so you don't want to read state here, but you want to read state here. The latest possible, basically. Also, you want to make it cheap, so avoid object creation. Even if object creation has never been cheap as is it today, it's still expensive, especially when you do it a lot of times. And avoid expensive operations. You can use value classes. For example, you have offset, which basically is the point. You have an x and a y. You have size, which is height and width. Those things are plugged into a long under the hood, into a primitive type, so there's no allocation needed. But you can also make your own ones if you have something to model. Beware of auto-boxing with generics, and remember to use remember. Cache it as well. For that, you can cache size-related operations, and you can also cache as layers. For that, you can use the draw with cache modifier, which will give you the size, and then you can do a bunch of stuff, and then you can provide the code that runs when it's rendered. There's modifier graphics layer and remember graphics layer, which are two ways to do the same thing. And then check it with a GPU profiler, which is just a button on Android. There are also logs that you can put in the composable function just to see when your code is rendering. That's the old way and still works. And you can use the layout inspector. You can also benchmark, of course, and repeat that cycle over and over until you are satisfied and it's efficient enough. So graphics layer, how? There are two ways. So as I told you, modifier graphics layer and remember graphics layer plus record. And so what happens is that the record lambda that you pass to it gives you a Dscope. So it's like you are into a canvas. It's exactly the same APIs, but the nice thing is that the other parameters of record allow you to give it a smaller size, which means that it will then be cheaper in the GPU memory. Yeah, because why? We want to avoid rerunning all the drawing commands on each frame. So like draw circle, that's some of your code that runs. You can save it, saves running your Kotlin code, but also save the system transforming it to some commands that can be sent to the GPU. But in some special modes of graphics layer, you can also have it be encaged into a GPU texture, kind of like Mario Bros was doing with just animate the entire game. It's kind of the same thing, again. It costs a slight amount of GPU memory or unified memory, but then when you want to do it multiple times, it's a lot more efficient. And it saves the cost of running GPU commands as well, which can be very high at some point. For that, you need to use a compositing strategy off-screen, or if you use some other stuff, say you use a blend mode, and I encourage you to look at blend mode. It's really cool stuff. I won't have time to show you all the blend modes today, but there are some doc on Android. And there are other cases as well where the compositing strategy is automatically moved to off-screen. That's where it goes into the let's make a GPU texture and cache the thing as a GPU image, basically. And so the final demo is, for example, this thing that I draw with a path. So you see, it's every second it's advancing. So every loop is 5 seconds. And so the way I'm doing it, I did something path pattern. So I try to like have something for my use case where I want it to be efficient. You see, there are many times it's exactly the same loop. So I'm caching that loop once, and then I'm redrawing it many times, and I'm only drawing in real time the last loop that is advancing. So then when it's done, it's not animating everything. And so for that, I made a composable function that then uses content Dscope, which is a special version of Dscope. There are graphics layer here. There's a lot of stuff in there. But you see, most of the things are done with just a repeat and a rotation. 25 seconds left. What can I, maybe the final slide. And you can come to me if you have more questions. I'm happy to do other deploys. Just wanted to talk about the testing approach. If I want to deploy every time on the watch, it can be a bit long. So sometimes I just use the IDE preview to debug, and then sometimes I do it on my phone. So I made sure that what can get done on the watch also can get done on the phone. Exactly the same. I just stated some assumptions in the beginning, and now I know what happens on the phone. I know what will happen on the watch exactly, and that means that I don't need to test too often on the watch. So first IDE preview, Android app, then Wear OS app in my case. But if you are doing another kind of product, the fastest place to test your code might be another place. So it's up to you to find. At the end, you want a working product, but you don't want to spend too much time testing it. Thank you. If you want to look at some example of doing watch faces with Compose, you can look at the Composer Clock repo. It won't show you how I made it that you can use Compose to make watch faces, but you can see all the things that you can put in any canvas, any Compose canvas inside. I'm about to launch some watch face made with that because it's fun, but I also want to get other people to use it. So there's that website, Brilliance. Not brilliance, brilliance, it's French, français, brilliance, whatever. If you go on brilliance.watch, you can register to know when I release those kind of things, and they have cool effects. When I move my wrist, the light reflections move. So if you want to look at that, or you can ask me whenever, I can show it on my watch. Yeah, thank you, and questions after.